Welcome to another episode of How Did It Make Sense? In which we look at these different stories we've got, the simple, linear first story, and the second, deeper story where we understand how it made sense for people to do what they did. And today I've got one of my sort of fellow Lundite graduates, Chad Todd. Chad, tell people who you are, where do you come from, how did you get to where you are in the business, and how can people find you physically or online?
Yeah, thanks, Gareth. Happy to be here and take time out for this. It's going to be interesting today. Chad Todd, let's see. I've been in the tech industry for about 20 plus years and spent, actually, believe it or not, 19 and a half years at a local healthcare IT vendor. And then kind of which largely influenced me actually professionally. And then during the COVID time, the tech industry got pretty hot. Given the remote work and whatnot, so then I moved around to a few companies and then landed here where I'm at now, CrowdStrike, and as an SRE Manager. I've been here a little over 2 years. Like places to find me, LinkedIn is one. Another one is X, formerly Twitter, and then Blue Sky. I'm also out there too. My Twitter handle the Twitter/Blue Sky handle is C Todd Kicker One. The little story about that is, people called me C Todd in high school, and then I was actually a place kicker and punter in football. So the kicker, and then my number was always one. So it kind of just like went together. So right now,
Ideal for social engineering and working out who you are then.
Exactly. I work remote, so finding me in person might be tough. I live in Kansas City, Missouri, which is known for its barbecue. And so it might be tough to find me that way, but I may stroll into a coffee shop to change the scenery rather than being at home at times. So it's one of those deals where, I work remote, been working remote since 2020, which has been there's good and bad to that, but
Excellent.
happy to be here.
Well, brilliant. Well, thank you very much for sharing your background and where people can find you. So what's this first story that you've got to tell, which is, the one that will probably get people thinking. So go for it.
Yeah, it's going to be, of course, a technical incident story, and it's written in that first story realm. I'll talk about it here. So like on September, like this has happened this year. So on September 20th, around 9:35 a.m. Eastern time, we put everything in Eastern time. Alerts fired in a particular Slack channel. So what's Slack? It's a digital communications application that we use. And so what happened was it was notifying that a job that syncs data had failed consecutively, and intermittent alerts were firing as well for an endpoint being down. So then an engineer at that point conducted the initial investigation and reported that some metrics were being impacted, the sync jobs were failing, and observed in a large Postgres write-ahead log. So we'll call that a WAL, W-A-L is what it's typically called in the tech industry, if you want it, the jargon we use. And so then around 10:40 Eastern time, another engineer joined the investigation, was scanning issues lasting an hour at this point because of being unable to sync. The manager and the team decided to spin up an incident. And so at that point, we started an incident based on that. So then this all stems from something that happened similar on September 13th, which played a role in the incident, but we won't talk about that now.
Mm-hmm.
Part of this, as we go on, is the changes released by an engineer as part of the September 11th feature deployment created a significant amount of updates and deletions within the database. Specifically on one database table, which is basically a Postgres database, was fragmenting the tables on disk, creating a lot of overhead. So at that point, the threshold of the system was exceeded in what could handle by creating the new assertions that inserted all of the data. So at that point, we kind of saw other transactions were running on the database at the time. We're also referencing this particular database table as well, which essentially caused additional overhead and consumed a large amount of memory on the actual Linux system. And so what happened was Linux essentially resorted to swapping memory pages onto the disk, which grounded the database to a halt. So basically at that point, we're like down. And so what was all this is a thanks to an early feature change made on September 11th. This also, what this resulted in is high load average on the system, and we were not actually able to SSH or basically get on the back end system on the node to basically use it and try to get this under control. So it's at that point, the system was completely down. We couldn't SSH to it, which is a secure shell that we use within the tech world to basically try to get onto the system and try to remediate it, right? So at that point, some engineers got on and to help alleviate the pressure on the database, they made some changes to this some settings, which were called these vacuum settings, which are applied to various database tables. A hotfix was applied to prune the particular data on the database table older than 30 days. No changes were made to like this Postgres configuration file. So Postgres in general, just to give context, is just a database essentially. And so at that point, we were at like real quickly, we fully resolved the incident and did a full vacuum, which was performed on the database to clean it up, the fragmentation, which caused by these changes as part of the new features being released to production. So it all stemmed from an engineer releasing these new features to production. So that's essentially the first story in a quick nutshell. What you would typically read in a media situation is kind of like what happened, essentially, what the root cause is.
So what I would say is, if you're reading the geeky media, that's the sort of thing you'd read. If you're reading the public media, that would be simplified as along the lines of engineers deployed a fix to fix something. Yeah. It corrupted something inside the database, which collapsed the database and people couldn't access it. And you guys had to go and fix their problems, and it took you a little while to resolve it. There's a lot more to it than that, though.
Oh, there is a lot more.
Even your first story there, I'm like, oh my God, what are these things? So what I think is really interesting is the terminology and the language you use. You know exactly what you're trying to do. And I would argue that probably 90+% of the people on here, I know Colette Alexander will listen because she gets it. But there's that bit that says, you know, even your first story has a whole bunch of extra stuff that people wouldn't get. So tell us the second story and a lot of context behind there. Basically, why did they deploy that? And it caused some problems.
Yes. So interesting enough, the second story has a lot more to it, as you said. So let me just kind of start at the origins is kind of where I'll start. So changes, so these features or these new things coming out from the development team, these changes were released as part of a September 11th deployment. So what we do is we deploy code out into production. So what happened was at that point is after the September 11th deployment, it created a significant amount of updates, deletions within the database, okay? Specifically a particular database table. And so when that happens, Postgres, which is a database type or a system we use, was fragmenting the tables on disk, creating a lot of overhead. So then at that point, the threshold of the system was exceeded, in which it could not handle it by creating these new assertions that inserted all this data. And this all, like, at that point, we're just deploying the code and the database access patterns implemented as part of the change may have not been optimal at the time, which kind of resulted in this continuous fragmentation. So then 2 days later, so kind of the history of that is 2 days later on September 13th, this is when we started initially having an alert fired. So we deployed, the code was deployed September 11th. September 13th, we started an alerts fired to the engineering team, indicating that this Postgres sync job had failed, impacting US1 only. What does that mean? So we have various regions within the tech world where we deploy our code out to. There might be US1, US2, EU1, EU2, things like that. So these are just kind of think of them as regions. So there's like regions might have multiple sites. So you might have, US1 might be Las Vegas, Reno, and somewhere in California, Santa Clara. So those will be one location. So, and those are just examples. And so you have these various regions. So these alerts started triggering in one particular region.
So just to capture that, what you're talking about then is stuff being gone into a database. It's updating files. It's breaking stuff up. And in effect, it's now snowballing So
Yep.
the stuff from the 11th, the failure starts there, but actually it's able to manage it to a certain level. And then on the 13th
Yep.
of September, it reaches a critical threshold that basically says,
Yes.
help, I can't manage this because there's too much stuff going on and I can't do it. And that's when you, as the operators or the systems guys, then start to, even though the failure's happened, this is now when you start getting stuff. So there's already a whole bunch of hurt happened
Yes.
in the background.
Yes, exactly. And so what happens on the 13th too is like these alerts start triggering consecutive failures lasting over an hour. So what happened was, as part of the group, we observe those and say, okay, slow operations are happening within the Postgres backend during that time, or the Postgres database. So during that time, what happened is the engineers like, okay, the automatic vacuuming, which I'm going to define here soon, which is enough to basically keep up and clean out the database. So as it's fragmenting, this vacuuming or basically cleanup job will go out and basically clean up the fragmentation. Like a defrag in Windows, it's essentially the same thing. And so at that point, it like keeps up for a little bit and the alerts start to resolve and go away. So at this point, the feeling is by the engineers, the local, if you want to call it the local rationality, is like everything's okay, everything's fine. We've subsided it for now, and
is that normal?
Yeah.
I mean, but the fact that you've got an auto vacuuming capability sounds like it's a normal thing that databases get corrupted,
Yep.
disks get, or servers get corrupted. I'm thinking of disks, but actually you're talking big stuff. They get corrupted, so it's a normal thing, and that's what you've built a resilience capability within the system to help with.
Exactly. And so to really define the vacuuming too is like it's really a garbage collection. So it's like you put garbage out on the street, somebody comes and collects it, and it's kind of the same thing. Is the vacuum is what it is. It basically is a garbage collection routine for our Postgres databases.
Mm-hmm.
And then there's two ways to do it. There's this whole automatic vacuuming, which is non-intrusive, cleans up underlying data structures, and keeps up routinely by setting certain parameters on as part of the configuration. But then you have the whole opposite of that, which is a full vacuum, which is performed by actual people, and it does not happen automatically, because what it does is it locks the database table. So the tables that sit out in the database are locked.
Yeah.
So then what happens is nothing can write to them anymore, right? So then
And there's got to be a big overhead as well, I would have thought, for something like that. So you're taking system resource as well.
Exactly. So it takes special care. Special care has to be taken when you actually perform a full vacuum to basically, because it'll affect service availability and service reliability at that point. So this all really ties back to, when that particular thing happened on September 13th, they thought it was resolved by the automatic vacuuming, but in reality, what happened was 7 days later, we started having these problems again. So then that's kind of where the second story comes in of like, okay, so I kind of talked about in the first story of then 7 days later, September 20th at 9:35 a.m. Eastern time, the alerts started firing again into the Slack channel and notifying the engineers that we're having this problem again. And so again, we're back to that second story is then initial engineers started conducting the initial investigations, and they also what's not talked about is more coordination was done underneath the covers, because they got more engineers involved at that point in time in more of a joint activity to kind of troubleshoot the problem. They were really at that point trying to figure out, well, do we really need to call an incident or not? And so then
what limits? So what's the downside of calling an incident then? Is that like a big ooh, or is it just what was the sort of the thought process and the potential reticence for calling an incident?
So yeah, I don't personally. I think incidents can tend to bring additional visibility into to a larger group of people. Maybe to the organization, to even your fundamental smaller department. So maybe your department's only 60 people, and you call an incident, and then all 60 people know, and they're like, oh, I need to jump in and try to help out. So, and they may not have any context to what's going on. So in that situation, and I think due to the fact that this had it was out there September 13th, and I kind of it reminds me of this whole idea of like the incubation period
Hmm.
of where things sit and sit and sit, kind of in the Barry Turner form of
Yeah.
like, okay, so things are happening, these latent conditions are being there. We had a little, maybe a little faux pas after the initial deployment, but we've kind of got to calm down because the automatic vacuuming is keeping up, we think, and everything's good. Well, then 7 days later, it's like it's not really keeping up.
Yeah.
So then all of a sudden we start seeing alerts, and then the manager's like, we probably need to. They what's funny is the group was in a like the group in my team was in a Zoom call with them initially, and we're like trying to help troubleshoot it, but then it's like the manager's like, we need to pull the trigger. He's up here to me,
Yeah.
and he need to pull the trigger on getting an incident because they've seen this happen in September 13th. They're like, we can't. We've got to really try to figure out what we can do to resolve this permanently versus it just being let's just try to get the alerts to resolve and
Yeah.
move forward and things like that. So then what comes of that is as they're doing this investigation, they start seeing these other transactions running on the database, which are also referencing particular database tables that these new features that were put into the system by this September 11th deployment. We're also trying to reference this particular database. So these tables sit out in these databases and they're all trying to reference it, right? So then it's just a continual, their split brain situation where
Yeah.
we're trying to just basically lock the database tables to use it and leverage it, which had created this additional overhead and consumed a large amount of memory on the system. So that's kind of where in the first story and even the second story, we talk about this whole idea of the Linux is at that point resorting to swapping memory pages onto the disk, which when that happens is it's no longer in memory. We're actually trying to use disk, which is slower. So then the database basically comes to a halt at that point. And so it has such a high load average and the CPU and everything is so pegged on the system at that point, you can't even get into the system. And so it feels
Wow.
like, yeah, it was crazy. And so,
So the helpful comments are, can't you just get in there and sort it out, and not particularly helpful.
no. And so what you're trying to do, part of bringing in the resilience or adaptive capacity, you're trying to figure out as engineers collectively is how do we alleviate the pressure on the database to basically be able to at least use the vacuum, the vacuum system or the vacuum processes basically to
give you some more capacity. Yeah,
exactly, to get you more capacity so you can actually get on the system to really figure out what's creating such overhead and bogging the system down to a halt. And part of this too is, they found, we're human, right? So we find bugs and we find things like that in systems. Well, there was a bug in this whole thing where the actual access path to the data was not optimal. Well, okay, so we had to the engineers really very quickly kind of identified that and said, okay, we're going to apply a hot fix and basically prune these assertions that were in the database older than 30 days.
Okay.
And so that's another piece that in the first story you don't really get, but really the reality is there was more to it. You're trying to basically alleviate the pressure on the database. You found some of the some contributing factors to the problem, and then also additionally that is you had to apply a hotfix to basically prune these assertions older than 30 days that were in the database essentially.
So
and on
just,
this database table.
So listening to what you've just said there, it's almost this bit of trying to buy yourself some capacity by solving a sort of potentially a parallel problem. You know that what you've got you can't solve directly. So, and you can't look inside it because the system is just so busy. So you sit there and go, right, how do I solve an enabling problem enabler, for want of a better term? So you sit there and go, right, close those bits down. So now I can actually look inside under the hood properly and now identify what the problems are, and then you can deploy that. So it's an interesting, is that sort of a quick summary?
Yeah, that's a quick summary. Exactly.
So
exactly.
Taking this to the wider piece from, the software space, is you sit there and go, right, what is it that's causing my problem? Because often the problems we have can't be directly solved, and they may be about workload issues. I mean, from the safety space, we talk about fixing the dodgy worker because they're not doing their job. But actually, what's the system which they're operating? So what's the rewards that we put in place? What are the punishment systems we put in place? people are trying to make sense of what they're doing at that time. So in effect, your IT is behaving locally rationally because it's trying to solve that
Right.
problem. It's doing what it's designed to do. But
Right.
actually, we have to change the wider picture. And that requires a bit of creativity on your engineers' part. So how do they develop that ingenuity, that I'm going to say, well, probably resilient side? How do they know to look bigger and then to say, let's kill that, because now we've got some space in front of us? Because I don't think these happen very often, do they?
No, exactly. No, not these particular. Like, I would say incidents aren't lying around to be found. Just like risk isn't lying around to be found. I preach this even to my
Yeah.
team too. Like, they're emerging properties of systems, and
Mm-hmm.
so that's the whole idea. Is this incident? While you could say, well, it's just like September 13th, but there were many latent factors and latent conditions in both situations of where engineers are having to essentially decipher what's actually going on underlying in the system to determine what to do next. And so this kind of rounds it out to me too. I kind of wrote this down is like, it's in troubleshooting situations like this, it's an art form, right? And it's not
Mm-hmm.
scientifically driven. And I think you as, part of that is looking at using like a safety 2 model is like looking at like how things are going right. So if you look at this, troubleshooting is an art, and so you have to like look at it in a non-scientifically way. And
Mm-hmm.
so you have folks on a Zoom call allowed, like when you have many people on a Zoom call, it's allowed to basically go down many different troubleshooting paths because you have different expertise in the Zooms, right? So one engineer might have certain expertise in one particular area of the system, while another one has a particular expertise in a different side of the system. And what that does is it actually is up levels you because you have different experiences and different expertise in the Zoom call to try to figure out what the real problems are. And so that's why I think we preach, especially in technology, and I think in many different industries, is this whole idea of nobody has a perfect picture or mental model of the system. They just don't. And in tech, especially, and I know you probably know this too, changes are happening underneath the covers all the time. And so you never know what really is going on. And your mental model is only up to date on what you know. And with incidents, when they do occur, they're actually awesome because you get to update your mental model and the
Yeah.
pictures of what's going on with the system right at the time. And then all of a sudden you get all this troubleshooting now after you go through this and you track down this particular problem in this particular area versus this area. Then all of a sudden it's like, oh my goodness, my mental model's been updated. And yes, we've released new features, but guess what? The next feature deployment that happened maybe in the next 2 weeks is going to change the system again because it's always changing at
That's
that point
really
in time.
There's
So
a comment that I saw an advert for John Allsport's incident class in January next year. And I was just like,
yeah.
oh, I'd love to be on that.
Mm.
I'm not in the industry and I'm not part of a team, so I don't fit that criteria. But his comment of incident management or incident learning is a team sport. I
It
think
is.
what you've just described there is that fact that each one of us will contribute dynamically to what's going on. A team is a group of two or more people who are working adaptively, dynamically towards a shared goal or mission. And IT in that space is exactly in that area. And I think what's really interesting listening to that conversation just now, or how it happens, is it's very much a case of transmit, because this is the information I've got. People then receive and sit there and go, right, take that. How does that match what I've got? Oh, that triggers something. Here, this is another story. So what I'm sure, if you'd mapped that, and I think this is what John's thesis was about, is about the networking that goes on and the network exchanges of information, and how that team develops its mental model about what's going on is a really cool thing to watch, I'm sure, for if you're a fly on the wall watching that.
Oh, and yeah, and another piece to that is I would say that the things that come from kind of the Lund studies that we don't realize is this whole idea that when you're in these Zoom calls and they're troubleshooting, even if we're not in person, it's the whole idea of the joint activities going on between the two engineers. There's some there might be some back channeling of DMs going on just to kind of that there's a joint activity that they're communicating that way.
Mm-hmm.
I would also take a piece from like Laura McGuire's thesis that she did for her doctorate is this whole idea around coordination choreography, which is what was happening. You're trying to coordinate everybody and choreograph choreograph them in the Zoom call, especially as my team being an incident conductor team
I
too
was
as
going to
well.
say,
So
who is the conductor in that then?
so my team, my SRE team does a lot of the incident conducting. So we have to essentially do that coordination and get that choreography going with all the groups. We have to pull from different strings to get the right teams involved. So as well, so we have to have what I would say is there's a lot of we get a lot of slack in the system that you don't necessarily think you have, that essentially allows us to adapt to those situations very quickly, especially in the tech industry. And that's why it's awesome to see. And if you're kind of into this world, then yes, being a fly on the wall and having somebody outside the industry to just kind of listen in, it would be awesome, because then you probably have different perspectives and insights of even ways that maybe we can improve and do better as well.
It's an interesting bit of actually different domains, where going to something like Red Flag in Nellis in Vegas, where they do big simulated air campaigns. And so you've got the airborne warning control system who, basically coordinating everything on. You can hear all the radios. And it's like a 3-dimensional, 4-dimensional piece, because you've got time and place. And people sit there going, how on earth does that all work? And how do, when the fighters get involved with an air-to-air visual combat, and you sit there going, how do they keep track of everything that's going on?
Right.
And so there's a very structured way of developing air crew and the whole sort of combat, air combat and the escorting and things going on. And there's a structured manner for doing that. How do you develop the software teams so that they've got those sort of skills? Or is it basically, here you go, throw in there, and it's sort of an apprenticeship model, and you're going to get your fingers burnt at some point, but that's all part of the learning experience. So how do you develop those people?
It is, you can't really train it really, because every incident is different in some form or fashion. And so it's really your ladder comment is kind of how it works. I mean, it is, especially in the tech world, you'll get thrown in the deep water, and you just kind of have to try to navigate your way through those situations, especially in the troubleshooting realm, that you have to use your, whatever experience you've had at previous companies to try to navigate something new in the new company. And so at that point, it's not something that is cookie cutter, I would say. It's more of, you're using what I would call your guidelines. Yeah. And part of that too is there's no best practices or anything like that. It's just using what practices and part of that too is having what you would, the adaptive capacity to basically adjust and go. And I always like to say is you have to be able to change quickly, be very agile in those situations, and course correct if something doesn't seem right, or you feel like, oh, it's always nice to get the information in a second story of what the red herring was for an engineer to what made them go down that route. But you also, what made you pull back out of it, to understand those decisions, because
absolutely.
That's the goal that you have to know. So just those areas are kind of tricky.
So if I'm going to say learn by mistakes, because you're in a complex space and we can make sense afterwards. That requires a culture that says we are going to make mistakes. So, from what you've described there, is the organizations are pretty mature in that sense, because you realize that actually it is a bit of, we have no idea what it's doing. Well, we've got a good idea, and how to solve that. How do you balance the public perception side of failures? And, because people just, the classic piece, when the recent CrowdStrike event occurred, people are, can't you just turn it off and turn it on again? And it's like, no, it's not as simple as that. So how do you manage that balance between, I'm going to say, naivety and ignorance as being polite terms, because people have got no idea what's involved?
Yeah, it is a very fine balance. I actually would say this was been blogged about by John Allspaw, in the sense of there are reports that are public facing reports that are for the public, and you do incident reports, I would call them, for that, where you have different audiences for different incident reporting, right? So this is kind of that vein, right? So we have, there's one to talk about, the July 19 thing, but any public facing incident that's out there, which we've had more since that time, is more for the public consumption. I would say it's to give a feel that we're doing something about it, and in the sense of like, hey, we've got this, right?
Yeah.
It's more the still have confidence in us as a company. And that goes along.
The serene duck, or the duck that's
yeah,
going across the water. Hey, that looks
yeah,
good.
yeah, it looks good. But then, you always really try to have what I would say, then there's a whole idea of like this whole incident analysis on the back end where it's really getting to understand like what decisions did the engineers make? How did they make those decisions? And using more of a, I would say like a seek to understand and do not judge.
Yes,
seek to
absolutely.
understand and do not judge. And so like that's the whole point is I want to hear your story. It's your I've had the Adaptive Capacity Labs training from John Allspaw, so it's really and kind of the whole Lund thing too is like you're trying to seek to understand and to get their truths because there's always multiple truths within the incidents, and that's what you're trying to capture and write down so people kind of have a basis of like what are those decisions? Well, we have the technical stuff, but like the cognitive decision making is what we lack. And so having the history and understanding how they made the decisions and that kind of builds up the documents that we produce. And then our part of that too is people can read those and go, oh my goodness, I didn't know, like you get information about, I didn't know that about the system, or I didn't know that's how that worked, or oh my goodness, I can use this documentation to actually help the next new starter at the company to say, hey, this is a great way to learn about our systems is use our incident analysis documents.
And do the organizations provide, because this is one of the things that I've recently done a learning teams with an organization, and one of their sort of pieces of feedback is the teams don't get time to consolidate learning after an event. And they often go straight into the next one. So do I'm going to say mature IT organizations give their operators, their engineers, their SREs time to digest and process this post an event? Because that to me has got to be a critical piece.
Yeah, it really depends is what I'll say.
Okay.
I would say if you had someone like me or somebody that's kind of been like part of the learning from incidents community, I would say, then I would say more than likely they strive to get that time to basically go do the incident analysis. And the leaders have bought into it. I would say within my organization, they very much have bought into it. And they allow one of my direct reports to basically, and I will do that, is like, hey, this is your project now, so let's go do the incident analysis and do all the things, and I will help you with it because it's somewhat new to them. But then I would say the other side is I've always called it incident amnesia. Why do I say that? Is because what happens in most organizations is they have the incident, they use a template, and they basically write all this information down. They file it. They may fix some immediate things, if they want to call it the countermeasures, action items, or recommendations, and then they move on to the next one, and then they move on to the next one, and then they move on to the next one. It's just kind of this continual circling of that.
And then 10 times time, when the same event occurs, somebody goes, didn't we have that one before?
Right. And so there's this continuous circle within, a lot of organizations where, are you being given time to actually do the analysis, to actually learn from your incidents? And granted, action items are fine. But I would say from a deep incident analysis, you might have more of a themes which create more strategic driven actions up to the leadership about, well, here's where we're kind of like, do we need new, what strategies do we take from this? I've been in one where we produced a lot of output around observability, and observability, like monitoring and alerting within the tech world is a big thing. And so we didn't have observability in this one company. And so they created a whole brand new team to basically focus on observability and get engineers and everybody to start thinking about it holistically.
Is that giving you a little bit more warning time? So actually just going back to your examples of sort of like 11th, 13th, and 20th is sit there going, can we pick up something a little bit earlier so that we don't have to deal with such a huge snowstorm, that we can deal with the backlog a little bit earlier?
Exactly. But I do think that's where the analysis comes. Yeah, exactly. And that's where the analysis comes is like, hey, we need to start up a brand new team, an SRE observability team to go
Hmm.
focus on these things. And you only get that if you do the analysis because you're seeing the patterns. That's the big thing. You don't if you do the file and fix method, then you don't see the patterns,
Hmm.
which is just you just say, oh, I need to fix this one technical piece. I need to go,
Yeah,
release
you
a
got to
hot
go
fix,
up
and
and
that's
above.
it.
Yeah, you got to go up and
You
out.
do.
Yeah.
You got up and out. And so,
So
and it's
you might pick up
yeah,
those. So it's a really great discussion because I can see there's the analysis, which to me is the identification of the sort of the problems throughout the layers within the system, the sort of social technical system we're talking about. How do you do the information learning dissemination? So that person who's the incident analysis, analyst who you talk about is going to be the monster knowledge person there on that event. But how do you then disseminate that to others? Because I think that's an area that many organizations lack. And I think that's why that amnesia piece fails. Even if you've got a systemic, holistic view of the event, how do you create that learning that goes wider?
yeah. So a little background. So after the analysis is done, you would hold a group meeting, and then you would invite anybody and everybody in the organization to come listen. They
Okay.
didn't even have to be. They didn't even have to be part of the incident. Like
Ah,
come. Like we would. And the big thing is you have to advertise that in a very marketing way, right? So like,
people are time
uh,
poor.
right. But you also like engineers in general are very curious that they read blogs about outages.
Yeah.
They read them all the time. And so like you kind of have to advertise it that way, but then when they get in there it's a little different. And then we structure those meetings a little different, and then that's how we disseminate the knowledge is kind of
Wow.
advertising
Okay.
holistically. And then part of that too is we just basically have this I would say this like data like essentially a doc database of all the incident analysis write-ups. And then you try to work with them holistically and say, hey, you could take some of these, and as you have somebody come into the organization, have them read about our incidents,
Okay.
because that's one way to broaden the scope of getting the information out there. One thing I did do at one organization is we would have like we would basically send out an incident a month to the entire organization of an incident analysis write up to say, hey, go read about it. It was
Yeah.
more of in a blog form. We would basically do a blog form of it,
Yeah.
and we would just basically send it to a DL and say, go read that, like just to kind of like, hey, your incident of the month is this one, so
DL
go
would be
read about it.
distribution list.
Yeah, distribution
Okay.
list.
Now,
Yep.
so
So
what's in?
we do
Yeah.
that Slack now too, but yeah, good.
So the way you've just described there reminds me of Ivan Papilides' stuff within the Forest Service
Mm.
and the learning
Yep.
reviews, and it's the need to generate specific learning products for your target audience. So your frontline operator, in their sense of the firefighters, is going to have something. It might be an infographic, or it might be a sort of a two-pager, and it's containing certain very tactical information. The supervisors, the incident management teams, and then the leadership within the organization have got other
Yep.
products, as opposed to what normally happens is your standard 20, 30, 50, 100-page report goes, dunk, there you go, read that. And the people are just they're going, nah, it's too much. And targeting
Right.
that learning. So that's a really cool way of getting that
That's how we
across.
do it.
Yeah.
Yep. And we're big fan of Ivan's. Love
Yeah.
him. Definitely took a lot from that too. Where I particularly love the whole learning reviews kind of documentation wording too, because
Yes.
we sometimes call them incident reports or incident reviews. In some organizations, I've kind of renamed them into learning reviews because then it kind of like triggers a different cognitive
Yeah,
mindset of
yeah.
like, I'm coming in here to learn about the incident. And while action items are great, but I want to really learn of what's going on.
Yeah, that's really
So
cool.
yeah,
So
yeah.
talk about, Ivan, we'll move on to the final part of the podcast, which is tell us a book or a paper or a video or
Mm.
multiples of those, which you'd recommend other people want to go and look at or watch or listen to and dig into. So over to you.
Yes, I have two that I picked out for this. My first one is what got me started down I would call the rabbit hole of lots of reading about safety science and all the things, and then heading into the Lund in 2020. Is A Tale of Two Stories, contrasting views of patient safety. At the time, I was part of this patient
Oh, of course,
safety
yeah.
group within the healthcare IT vendor that I was at. And so I read that paper, and it talks about the first story, second story, hindsight bias, and all these things. And I'm like, okay, I am just blown. My mind was like, boom, this is so different. But it's like I couldn't get enough.
Yeah.
And so every weekend, I was probably putting in hours, Saturdays and Sundays before I ever went to line reading. And then all of a sudden, all these PDFs started flowing to me from our Learning from Incidents community. And I'm like, oh my goodness, I just can't get enough. And I was engulfing it. And the other one I would say, and that paper is by two greats. One
Yeah.
was the late Richard Cook and David Woods, who was one of the founders of Resilience Engineering. The second one is from which is very it's a treatise by the late Dr. Richard Cook. It's called How Complex Systems Fail.
Yes. Yeah.
And that one is huge in the tech community. It's even been on Hacker News and things like that. So it's got, it gets referenced quite frequently in that world, in the tech world. He actually went to Velocity conference when it existed. And John Osbaugh was on the board at that point. He went there and did a whole presentation on how complex systems fail, and it's out there for YouTube as well. But
yeah, I'll go and provide that link. Yeah, it's very good piece. The Tale of Two Stories is one of the things that got me into my sort of Lund thesis and shaping that. And actually, if you tell a first story, what I found in my research is that people are likely to be more judgmental and they're less likely to tell their own story. Whereas actually, if you share a second story, people go, I understand that. There is more to it, and they're more likely to share those. But the downside is that the attention span for the average diver is pretty limited. So one of the bits that I did in some follow-up research was I want to put another paper together is, can we look at the learning capabilities of people, the learning interests? And I found that a number of people just stopped after. So the first story was 350 words, and the second story was 1,000 words. And there were a number of people just stopped at the end of the first page, which is like 350 words, and they didn't bother reading anything else. I'm bored. And it's like, So fundamentally, there's an attitude that says we can learn from others. So in your community, because it's been developed and there's this culture that says, let's go and learn. You talk about the engineers go, I'm curious. I don't think that exists in the diving space or a number of other spaces because it's that knowledge is just not there. So there's a lot of work needs to be done. So I'll find the papers, I'll upload them into the show notes or put the links to those and the videos from Richard Cook at Velocity, both that one and then I think there's another one in which you talk about Rasmussen's framework about going solid is another brilliant video just to bring this stuff to life. Yeah. Yep. So, Chad, thank you very much for your insights and exploring some of the hidden areas of the digital space. And I think when, hopefully people listen to this and go, oh yeah, it's not simply a case of just reboot it and off you go.
Right.
Because all the debris is still lying around inside the database and the vacuum cleaner hasn't taken it up. So
Exactly. Exactly.
Brilliant. Thanks so much, Chad. Take care and we'll catch you soon.
Thank you. Pleasure.